lean. That means you have less petrol, and after that you loosen it 2.5 turns back, so the needle slides inside there. This is quite obvious. This needle goes inside that hole and the slide sits like this. Obviously the spring is to put the diaphragm, the pin, back in place. Basically does nothing more than holding your accelerator in. So this is what a carburetor does, but if it was that simple, I wouldn't be making this video. Hey guys, welcome back to another episode of V-Pills. In this episode, I'm going to show you how a carburetor works, and I'm going to tear apart all the pieces out of a carburetor. This is a old carburetor that I have. It's from a Pulsar 180. So I'm gonna strip it apart, show all the components, all the pieces, name them, and tell you what it does and how it does it. It's a very beautiful piece of engineering, so let's get to it. Now to give you an overview, a engine needs a mixture of fuel and air to run. So basically that's the complete job of a carburetor. So basically it pulls in air from this side, mixes fuel with it, and then sprays it inside the engine. And that's how the engine creates the blast and it runs. So I have broken down a carburetor down to the smallest pieces possible and labeled them. So now we'll start assembling it one by one, and I will keep on explaining what each of these pieces does. This is the main body of the carburetor, and this is the engine side, and this is the air filter side. So basically the air comes from the air filter and goes through it, mixes with fuel, and goes to the engine. But now you see there is a blockage right inside there. That is the butterfly valve, and the accelerator is connected to this knob or bracket here. So when we pull the accelerator, it basically pulls this knob. It is very tight right now because this carburetor has been sitting for a long time, but it basically pulls this like this, and you see now the carburetor, the butterfly valve is open. That's how the air from here rushes to the engine. So depending on how much the butterfly valve is open, the amount of air and fuel goes to the engine. If it is completely open, we are on full throttle, and then if it is completely closed, basically we are idling. Now you might ask, what pulls the air from the filter to the engine? To answer that, basically we have this rubber hose which connects the carburetor to the engine, and we have another similar bigger one which connects the carburetor to the air filter, and this whole thing is completely airtight. So when the piston goes down, it works like a syringe. So basically the piston goes down, it pulls in air from here. So that's how the air goes to the engine. So if the butterfly valve is closed, it would not be able to pull as much air, but if it is completely open, when the piston goes down, a lot of air rushes through the carburetor. Basically when this is in fully working condition, when you pull the throttle, it opens the butterfly valve, and then this spring pulls it back and it closes when you release the throttle. So, and the amount of air varies accordingly. Now we don't have to connect this rubber hose to complete the carburetor, but we start with the fuel sump. This is a fuel sump. So if you look at the main body, this is where the fuel pipe is connected. Basically the pipe comes from a pipe of this sort comes from the fuel tank, and it is connected over here. So the fuel enters this pipe, and then at the bottom it comes through this hole and collects in the fuel sump, right? Now this fuel sump has a gasket such that the fuel doesn't leak, and when we start with it, this is the drain screw. Basically it goes in here. So let's say sometimes what happens is some water builds up inside the carburetor. So if you want to drain that water, you just loosen this screw and the water comes out of this hole. And right now this is blocked, but when you loosen this screw like this, the petrol will come out, and obviously the water settles at the bottom, so water will come out first. Basically this is for cleaning the fuel, right? You might need it in some cases, or you may never need it. So that's how it works. Next is the float. The float, it has a needle. Basically this is used to operate this needle, and if you see, as I told you, the fuel comes from this line and enters the sump from here. So this pin goes inside this hole like this. So when it is completely in, it basically blocks the path of the fuel, and the fuel stops. This is how the fuel doesn't overflow. Let's say if you don't have this pin, the fuel will keep on flowing inside and the sump will overflow and everything will not work. So basically This pin is what controls the fuel flow inside the fuel sump. The operation of this needle is no magic. It is operated by this float. To understand this, you must have seen a float in your water tanks above your house. So basically this pin goes in, this needle goes in right here. It hangs like this and blocks the fuel line right there, and this float pin is what hinges the float to the carburetor body like this, and we have this screw which holds all of this mechanism in place. So you can just tighten this like this. Now let me show you how it works. So now if you see, the carburetor sits like this, and this float is basically hanging down, so it is, the pin is basically out and the fuel is free to flow from here to the fuel sump. But as the but as the level of the petrol rises, it pushes this float upwards, because obviously this is it is filled with air, so it is lighter than the petrol, so it pushes it up. And as it pushes it, the float up, you see the needle slides inside there and blocks the way. The needle is going inside, it blocks the way, and that's how the flow of petrol stops. Before we connect the sump, there are these jets that we need to connect. One is the pilot jet and other one is the main jet. Now the pilot jet is the first thing that comes into play when the carburetor is operational, so it goes in right there. So basically if you see, it is just a small tube with precision holes, and this part sits inside the petrol, and this one, these have small holes here which sprays the petrol when it is pulled using the Bernoulli's principle. Now I have to explain you what is that, but before that let me show you where it goes. It goes in right there, and you can just easily screw it in. Okay, need a smaller screwdriver. Right there, it goes like this, and the pilot screw is fixed inside. Now let me explain the Bernoulli's principle. What happens is, when a lot of air is rushing through this, so you see there is this hole right there, correct? This hole sits inside petrol. There's a tube inside petrol, and when a lot of air rushes from here to here, it sucks in the petrol from that hole, and it mixes the petrol with the air. So you see in that animation, when the air is flowing quickly through this tube, there is a area of low pressure created above this hole, which pulls in the fluid and creates a spray of it. That's how the fuel and air mixes and it goes through. So when the when the motorcycle is idling, at that point of time, it is sucking in petrol through that hole. That is why it is called the pilot jet. And then we have this main jet. This is also a similar thing. You have a hole through and through, and then you have small holes in there. I don't know if you can see them, but it's just right here. If you see, there's one hole here, one right there. Here everything is blocked right now, but these are the holes from where the fuel is sprayed, and it is sucked from this end. So now you can put in the main jet like this. It goes in here. So now you see this main jet is basically connected to that hole right there. You see that? So it sucks in petrol from here, mixes with air, and goes through. Now we basically have all the components which were inside are already connected. So now we can close the fuel sump. It goes in like this, and make sure the gasket, if you are working on a new working carburetor, make sure the gasket is there, sitting properly, nice and proper, and then you can just put it like that, and it is held in place only by 2 screws, just like that. One, which again goes with the washer, and 2. So the bottom part of our carburetor is complete. Now moving on. Moving on is another important part, which is this slide. Let me explain how that works. Now this is the slide. It is another important part. So now if you look inside the carburetor, right there is a hole basically which is coming from the main jet. So this is quite obvious. This needle goes inside that hole and the slide sits like this. It shouldn't be that jammed. It should go in easily, but as I told you, this carburetor is pretty old, so it is taking some efforts to go in. Now also while putting it in, you can make sure this notch, it goes into this notch right there. That's how you know you are putting it correctly. This is how the diaphragm sits, and this notch goes, this extension actually goes into this notch, and this is pretty airtight. So how it works is, when you open the butterfly valve, it basically creates a low pressure in this area, and when there is a low pressure in this area, it pulls up the slide. So right now it is jammed, as I told you, but it basically pulls up the slide like this, but this stays down. Something like this. So this is how the diaphragm is pulled up, and when this is pulled up, the pin is out of that hole and more petrol can flow in from the main jet, and that's how, depending on the accelerator, more petrol flows in and goes to the engine. That's how we speed up, and then when you release the accelerator, just goes back down. So this is how the diaphragm and the pin works. Next we have this spring which goes in like this. Obviously the spring is to put the diaphragm, the pin, back in place. As soon as you release the throttle, this slider and the pin is supposed to go back into its original position, and that's why we have this pin right there now. And this one is the top cap. It goes in like this, and you can just put in the screws. One. Now comes the idle screw. This screw goes in right there. It has a spring to hold it in position. It goes in like this, and then right there, need to apply a little bit of pressure initially to put it in, because we have a spring right there. And this one, the mechanism is pretty simple to understand, because it basically does nothing more than holding your accelerator in place. So let's say this is the butterfly valve, your accelerator basically. And now if you see, if I push this screw in, it holds the accelerator a bit open. Basically it opens the butterfly valve. So if you keep pushing it in, it will hold the accelerator in more open position and your RPMs will increase. If you loosen it, right now this, as I told you, this is stuck, so it is not coming back. But if you loosen it, basically your throttle will come back to its closed position like that, and that's how you will have low RPMs. So this is the idle screw. Now next we have this magnet. This magnet goes in here. This is basically to determine the throttle position, which is used by the ECU for various functions, to increase the average and all that things that the ECU does. And this is a bracket. A sensor basically goes in here, which is connected to the wire and which goes to the ECU. So you don't have to worry about it a lot, but this is where this bracket goes. It has nothing to do with the function of the carburetor, but it is a part of it, so I am explaining it like there. One. Next up is the choke. The choke, basically, this one is a plastic piece. We have a spring, and this pin is basically blocks one of the tunnels inside here. So if you see this hole right there, I hope you can see this hole. This hole pumps extra petrol in. This is towards the engine side. So if this hole is unblocked, it pumps extra petrol into the mixture, and it makes the mixture rich of petrol. So that's when you need more petrol to start, let's say in cold conditions and all that. That's when we pull up the choke, and the chokes sit in here like this. Easy peasy. Okay, now when the choke is in, this hole is blocked, and the mixture is normal, whatever is needed. But when you pull this choke out, like this hole will be open and extra petrol will flow into the mixture, so mixture will be rich and it will help you start the engine. Now final piece is this air to fuel mixture thing, air to fuel mixture screw, and it goes right in there, but there is supposed to be a spring here which I kind of lost. So you put that spring in, then you put this screw in here. Now how this works is, let me just tighten first. Initially what you can do for the setup is just tighten it completely. When you tighten this completely, I mean just snug, and after that you loosen it 2.5 turns back. So now let's say it is tight, not yet, yeah, now it is completely tight. So 1 turn, 2 turn and half. That's where you keep it, and you can start your settings from, when you put it back to the engine, then you can start your settings from there. But now I have to explain what this screw does. Basically what it does is it maintains the fuel to air ratio. So let me explain it in detail. So basically, let's say this is the mixture which is going into the engine. It has one part of petrol and 14, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 14 part of air. So this is the ideal mixture because one part of petrol needs 14 part of air to burn. So this is the ideal, so we call it stoic, right? But let's say you have one part of petrol and then you have 20 part of air. These numbers may not be absolutely correct, but I'm just giving you an example. So let's say you have one part of petrol and 20 part of air. In this case, your mixture is lean. That means you have less petrol. And let's say if you have one part of petrol and instead of 14, you have only 10 part of air. So that means your mixture is rich. That means you have more petrol compared to air. This is basically what is rich, stoic, and lean mixtures, right? So this is what is controlled by this screw. So in this case, if you see the screw is more towards the engine, it basically controls the amount of petrol going into the mixture. And if the screw is more towards the air filter, it controls the amount of air going into the engine. So now let's say we loosen the screw, more petrol will go in and the mixture will be rich. And if you tighten the screw, less petrol will flow into the mixture and the mixture will be lean. And that's how you have to find a sweet spot where the mixture is stoic and you get the best mileage and best power output in that case, right? So you can adjust this. Maybe I'll make another video. So that's a wrap, guys. I have shown you everything inside the carburetor, broken it off and then put it back together. I tried to explain everything, but if I might have missed something, you can put it in the comments and I will make sure I reply to that. So remember, what a carburetor does is this. So hope you like this video. See you in the next one. Like, share and subscribe. Bye bye.
If you like this video, please consider subscribing.
This guy's not slowing down. Yeah, that's confirmed. He's not stopping. Code 3.
So this is what a carburetor does, but it was